Hello everyone. Welcome to the class of Highway Survey and Design. I am your teacher Song Liu. Today, we are going to learn about route selection in various river valley terrains. First, let's look at how to choose a route in an open river valley. What exactly is an open river valley? As the name suggests, an open river valley has a simple and gentle river valley bottom, with a wide terrace between the riverbank and the slope, mostly consisting of farmland. In such situations, there are generally three routing methods. Let's take a look at the diagram. The green line represents the river. The first method is to lay out the route along the river. The second method is to go directly through the flat area between the mountain foot and the river. The third method is to lay out the route along the mountain foot. The characteristic of the river line is that it has a uniform and gentle gradient with a good alignment, but is vulnerable to flooding on the riverside, requiring protective engineering. The direct crossing route has high alignment standards, but occupies the most land. In paddy field areas, soil replacement is sometimes necessary to stabilize the subgrade, which is generally not suitable except for freeways and first-class highways. Routing along the mountain foot slightly increases the length of the road, with some undulation on the profile, which can avoid or minimize the occupation of arable land, making it a commonly used routing form. For riverbend terrain, there are three ways to lay out a route. The first method is to follow the natural curvature of the river bend. In this case, the route is circuitous, with steep bank slopes and severe erosion, requiring extensive protective engineering for the subgrade and poor safety conditions for the route. The second method is to build bridges across the river, taking a straight line with two crossings. As we can see in the figure, two bridges are built over a short distance. Building bridges is expensive, but the road is short and straight, suitable for high-grade highways. The third method is to redirect the river, taking a straight line, as shown by the dotted line in the diagram. By connecting the upstream and downstream of the river, there will be no flow at the river bend. This solves the problem of building two bridges, allowing for a more direct route, shorter distance, and improved safety conditions. Whether building bridges across the river or redirecting the river, each plan should be meticulously studied based on topography, geology, and hydrologic conditions, and combined with agricultural water conservation construction. For some large river bends with wide and shallow river banks, to improve route standards, the route can be laid out on the riverbank. As long as it's properly handled, it can also serve to protect and create farmland. But attention must be paid to the protection and reinforcement of the subgrade to prevent erosion damage from water flow. For mountain spur terrain, routing can follow the natural terrain around the mountain spur. This route, due to its length, is advantageous in gradient-restricted sections for gaining height, excluding tunnel situations. But it is susceptible to adverse geological conditions and the threat of river erosion, leading to poor route safety conditions. It's also possible to take a direct route through cuttings or tunnels, which provides a short and straight route with better safety conditions. But if the tunnel is long, the engineering cost is high. A comprehensive analysis should be conducted, and plans should be compared in detail. Generally, a direct route is preferable when the engineering volumes of direct and detour plans are equal or close. For individual prominent mountain spurs, the cut spur fill bend method can be used to deal with routing, with attention to the balance of vertical excavation and filling, to prevent a large amount of waste from being discarded into the river, causing blockages. Dear students, we have learned about routing methods for mountain spur, river bend, and open river valley terrains. There are several ways to lay out routes for each terrain type. The final choice of routing method should be based on local conditions and specific analysis. It is essential for you to practice and become proficient in applying these methods. That is the content of this lesson. Thank you all.